Welcome to Primer 4 on the Layer 1 Primer series. This is the similarity. In this right side you see I have given I love cricket and I like cricket and I hate vegetables. How it knows? As a human we know how AI knows which sentence is similar. Which sentence is more similar? I love cricket, I like cricket, I hate vegetables. Because everything is converted to the vectors from sentences. Then how about similarity? Most people answer it is A and B are similar. But how computers do that? Let us understand. Sentence become locations. Here every sentence we are converting to the vectors, that is numbers. In the previous episode we have already seen, and assume that every vector is a point. Imagine every sentence become a point in a giant 384 dimensional space. Now we need to know which points are similar. Here you see I love cricket and I like cricket. If I convert into 384 dimensions to simplified 2D, two-dimensional, they are appearing closer together. I hate vegetables is very farther. Let us see how it does. Can we measure with a distance? That is the first idea. If these 2 points, like in this example, are closure in the vector space, those points are very closure. If I have a ruler, I measure the distance. Then if anything is near, they are closure. If anything is far, they are not similar. Is it correct? Now you see the problem. The distance can definitely fool us. Take the 2 sentences. The left side arrow, it is I love cricket. The right side arrow, I absolutely, genuinely, deeply love cricket. The distance is increased, but meaning remains same. The longer the sentence, but the same meaning, but distance grows anyway. So distance has a problem. Earlier we have seen that if distance is closure, we are similar. But in this case, even though the meaning is similar, but distance is very, very far. Let us see now. The better question is don't compare length, compare direction. Here you see, even though the distance is far, this point here and this point here, but they are pointing in the same direction. You see here, both are pointing in the same direction. If they're pointing in the different direction, then they are not similar. Instead of asking how far apart, ask, are they pointing in the same direction? That is exactly what cosine similarity does. We are entering the world of cosine similarity. Here the direction matters. If output is 1, that cosine is producing output 1, then these are in the same direction. If cosine is producing for the 2 vectors 0, then there is no relationship at all. If cosine is showing -1, then there is an opposite direction. Here you see the same sentence embeddings. We have passed to the I love cricket, convert to the embedding in the numerical vector representation, and I like cricket. Both we have passed to the cosine. Then it produces output 0.94. Then they are more similar. And I love cricket and pizza is delicious produces 0.18 only. Means they are not similar at all. I like cricket and pizza is delicious also produced very low cosine score. Here the higher the cosine score, the more similar the meaning. Shall we see everything in demo? Here what we are seeing is we are importing the sentence transformers and cosine similarity. Then we are using the all mini LLM. It has 384 embeddings, that is 384 dimensions, and we are using 3 sentences. I love cricket, I like cricket, pizza is delicious. First row represents I love cricket in relationship with other 3, because I love cricket and I love cricket, if I pass to the cosine similarity, they will produce 1 because they are 100% similar. If I give I love cricket to I like cricket, then they are most similar, 0.94 it produces. If I love cricket and pizza is delicious, this is we are comparing 1 versus 3, it produces very low score, means they are not similar. We have given it to the model and it produces something like this. Then sentences convert to the vectors and vectors into the similarity. Let us jump into the Google Colab now. Here again we are using GPU T4. We ran, this importing is done. We do the modeling, all weights are loaded, load the sentences also, embedding is also created for this. Now print the embeddings. You see here same exact, it is almost 1. Then again first sentence, second sentence 0.93, they are highly similar, but first sentence, the third sentence, they are not at all similar. Where similarity shows up, it is everywhere. ChatGPT, semantic search, RAG, web search, recommendations, question answering. Without similarity, embeddings are just numbers. Similarity gives them meaning. Now we understand similarity. It is converting sentences to embedding model, and the dimensions what we have used, that model is 384 numbers produces, and we find out the similarity. In this primer series we have covered starting with Colab, where we have given some introduction to the Colab, the rows, notebook, everything. Then we have little introduction on the Python, then how AI understands text, so that we have shown in the vectors in the higher dimension space. Then in the higher dimension space, how the individual vectors we measure the similarity, that is distance is a problem, but if we measure the direction using cosine similarity, that resolves all the problem. That's it about this little primer series. If you like, please subscribe, like our video and comment for any further queries. See you in the next primer. Thank you.